On page 11 of your workbook, you've got instructions for carrying out your first titration. This video accompanies those notes, so you've got a visual of what to expect when we do this in class. Your first step is to place a clamp stand on your desk, which will hold your buret. Using a funnel, you now need to add sodium hydroxide to your buret. It's important that your buret doesn't have any residual water from cleaning, so if necessary, rinse your buret with some of the dilute sodium hydroxide solution that you're going to be using in the titration. It's very important not to have any water, as that will affect the accuracy of your results. When adding the sodium hydroxide to the buret, make sure you use a funnel. There is no need for you to muck around getting the sodium hydroxide to the 0.00 mil mark, and instead near it to the top, and we will record your initial reading in the results table. Before you proceed with the titration, remove the funnel. If you leave your funnel in the buret as you're carrying out the titration, it potentially could drop little droplets of sodium hydroxide into the buret while you're doing the titration. That also will affect your results. The other point I should make, and it's very important you do this, ensure that there's no air bubbles in your buret tip. If there is, remove those before you proceed, as those too will affect the accuracy of your readings. You need 4 conical flasks for the next stage in your preparation. Into each of those conical flasks, we need you to put 25 ml of hydrochloric acid. The way you do that is you use a pipette and pipette filler and put the 25 ml in each flask. We then add, in step 4, 5 drops of phenolphthalein indicator. As I said earlier, it's not important that you get the sodium hydroxide up to the 0.00 mil mark. That wastes a lot of time, particularly on your assessment day. And instead what we do is we simply fill it near the top and take the initial reading and place it in your results table, where you can see I've got this red circle ready for your first reading. It's a common mistake for students to start titrating before they take their initial reading. At the end of the day, it doesn't actually cause any harm, it just causes a lot of frustration, as you will need to start from the start again and be sure to take the initial reading. When you take readings from the buret, it is important that every time it is read to 2 decimal places. The way you do that is the meniscus is either on the line, in which case the second decimal place will be a 0, or it will be between lines, in which case the second decimal place will be a 5. Let's zoom in and have a little look what I mean. If you notice this volume read from this scale, we can see that the volume is greater than 30 mils, but not as big as 31. Using the increments here, these are all 0.1 mil increments, and so you can see that it is 30.3. Now, because the meniscus is on the line, the second decimal place is a 0. Had that been down just a fraction more and been between the lines, it would have been 30.35. With practice, you'll get good at recording the buret readings into your table, but just as a reminder, we can tell if you've been sort of cheating, if you like, because the second decimal place could be, if it's different to a 0 or a 5, that's a classic sign that a student's been making up results. When you proceed to carry out the step 6, your rough titration, what you do is you turn the tap open and start adding the sodium hydroxide into the flask, and you'll see a pink colour develops. That is due to your indicator changing colour. It's important that you swirl this flask as you proceed to make sure that acid and base are reacting together, and just keep an eye out for that pink colour. As you see the pink colour develop, you close the tap. When it's permanently pink, that is the end point. When you're doing your rough titration, it's not too much of a concern if you overshoot the end point. It gives you a feeling of what value you're expecting for the end point, but your titrations after your rough need to be accurate, and you need to be adding your sodium hydroxide drop by drop. So the initial colour when you start your titration will be colourless, and what you're aiming for is a permanent pink colour. What you'll find helps is if you place a white piece of paper underneath the conical flask to get a better contrast to see that pink colour develop. And another good practice is to wash the sides of your flask down with distilled water using the water bottle to make sure all the droplets of sodium hydroxide and acid are actually falling down and mixing well. You'll need to carry out a minimum of 4 titrations. Your first one we do is called the rough titration. It's done quickly and not with much care, or rather accuracy. And then your preceding 3 after that need to be carried out accurately, drop by drop, to get these endpoints. Once you've got your data, then we work through the calculations. Note, to get excellence in the standard, you need to have all your buret readings read to 2 decimal places. And when we go on to calculate the average, we only average what we call concordant results. So looking at this table here, you can see that you've got 3 values that are all within 0.3, and the rough one is not. We would not average the rough titration. How you get these tighter values is a small calculation, very easy. You take the final reading and you subtract off the initial reading. So in this instance, the tighter value is 22.45, and that is what you would record in the results table there. So you can see I've got the 22.45 recorded. Then you calculate the titer by taking the final reading and subtract your initial reading for the other titrations. As I said, when you calculate the average, only calculate the average from the concordant results. So if that means those 3 readings, then you only divide by 3 to get the average. Always record the average again to 2 decimal places so it's consistent with the values you read. Notice now that the average won't necessarily be a 0 or a 5 at the end, depending on which values you're averaging. Convert your volume from the buret from mils to litres, and to do that, divide by 1,000. Second calculation. You will be guided through the calculations like you are here in this task. So using the average, we need to calculate the amount. So that would be using the amount is concentration times volume. Write the formula out and then substitute your values in. So the concentration is provided for the sodium hydroxide. It is 0.0950 moles per litre. Your volume is the average of the buret readings. Remember, the sodium hydroxide was in the buret, and so it's the buret readings that provide the volume. When you multiply these values together, you'll get your amount, and the units will be moles. Very important that values are written with units through all stages of your calculation. Step 3 is to determine the amount of hydrochloric acid. Now this is new. We have not practiced this prior to the titration. To do this, you need a balanced equation, which will always be provided, And from this we can see in this instance 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So the mole ratio in this reaction is what we would call 1 to 1. So the amount of sodium hydroxide is going to be equal to the amount of hydrochloric acid, okay, 1 to 1. So we can take the value from our step 2, and that is the amount of hydrochloric acid. And your final calculation then is to calculate the concentration of the hydrochloric acid. And to do that, we use the amount of hydrochloric acid over the volume. We have the amount from step 3, and the volume is the volume of hydrochloric acid we used in the titrations. Remember, we used the pipette for the hydrochloric acid, so that was a 25 ml pipette. It does need to be converted to litres, so divide your 25 by 1000, and that will give you your volume in litres. When you divide your amount by your volume, your units will be moles per litre. I can't emphasize enough, for excellence, a student must give their answer to 3 significant figures with units. So that is the end of the calculations required at this stage for your titration. I'll just remind you of some of the variables that you had controlled, which are the sorts of things that you need to remember for your write-up on the final day. You removed your funnel to avoid sodium hydroxide falling into the buret after the titration started. You ensured there were no air bubbles in your buret, as that too could have introduced errors to the readings. All readings of the buret were taken at eye level to avoid the parallax errors of reading the scale. All readings were taken from the bottom of the meniscus. All buret volumes were read to 2 decimal places. And we were swirling the conical flask to ensure that the reaction rate was optimal. So now you should be ready to carry out your titration when we get back into class. Thank you for enduring this long video, and hopefully this little joke here makes a little bit more sense to you now. We'll see you next time.